Okay, hello dear, good morning. Today we are going to have another session in our lecture. So I'm going to share with you the lectures that we have today. We are in 5.5, talking about integral and the application of the integral. So one of them is definite integral and substitution method. So definite and indefinite integral. The other one is substitution method. So we are going to start with the methods. I remember in the previous lecture, I gave you many ideas about how to find the integral, right? We start with the x squared. Am I right? Do you remember that, Ali? So we say x squared. How to solve this one? For example, we start with a small example like that. X equal to. We say if x is equal to dx, we say directly is equal to x plus c. Do you remember that? And also we say if we have a number, we forget about the number because the number is not big deal. We are bringing it out and we have 2x plus c. Understood? And again, if we have x dx, these are the basic and the simple things in the integrals that you are going to start it. I thought I accept that you are not heard about the integral. This is the first time. That's why I'm going to remembering you, like a review for you. So we say is x squared plus xy because we are in our mind, we say this is a box, and outside the box or the parentheses, there's a derivative is equal to dx. That's why we are going to add 1 and we divide by new, what do you say, by new number. So here we are, we say plus c. And of course, if we have x to power 5, we know how to deal with this again and again. We say this one is like a parenthesis, and here's the dx. We forget about that one. Then later we see is equal to x6 over c. I gave you many things like that. Also, I remember that I gave you a simple example on the sine and cosine. We see sine of x, cosine of x, dx. Do you remember that? So we say also again, this is u, this is du. In my mind, I will change that one as a bracket, a parenthesis. I say the derivative of here outside is exists. That's why I'm going to say is equal to sine square like that. For example, I can write down like that to be more clear. I say sine of x plus c, but I am going to add the power of the sine to 2. For example, again, and if I have another example, if I have sine square or 3 cube of x dx, if we have sine cube of x cosine of x dx, because I have a rule in my mind, I say u du. So I will ignore the exponent and I'm going to say is equal to what? I say is equal to sine to power 4x over 4 plus c. And there's a note about that. If we have a what? Maybe we have what? Maybe we have a, or there's a, what do you say? The manipulating with the exponent means that, for example, if you have sine square of x, you can write down sine as like that. Sine of x, all of them square. Careful, the square or the power is on the x, on the function, not on the angle. Careful, that's why I can do it. But be sure that sine of x squared is not equal to sine square of x or sine x all square. These are not equal because here the exponent is on what? Exponent is not on the, is on the angle. This is something else. Understood, dears? So please write that note if you want. That's all. So these all about the previous lectures, like a reviewing, quick reviewing. So I'm going to the main things that we have for today. We have definite integral. You can see here we have a definite integral. And also we have substitution methods. So we have two things here. So I'm going to give you the methods. You heard about that one. I gave you many information about that one. So I think this one is easy for you. Can you imagine it's easy for you? Can you imagine that one is easy for you? Why I say it's easy for you? Because I gave you many examples. I say x, sine, and anything. So if you have u here and du outside, we can play with it. Understood? Okay, so here we are. We are going to examples. Now we have an application or the examples which make you test you. Did you understand or not? Okay, did you understand or not? So here we are. We have this example. I'm going to write down for you. We have what? We have x power 3 plus x integral of x to power 3 plus x, all of them to power 5. Now here we have another one, 3x squared plus 1 dx. So when you are looking at in this function, you can see here that we have two things inside the integrals. The first is with the exponent, the second is without, right? Look at here, the first is with the exponent, the second is not. So here's the exponent one and this one. And I'm asking myself, without, if I neglect the exponent, the power, okay, if I neglect the power, and I rename this one as u, I'm asking myself, do u exist or not? That's the question, because I have something with the exponent, with the power, and something else. So I'm going to distinguish, separate in my mind. The first is I'm recalled as u, and I'm checking, is du outside or not? I don't know. So maybe exists, maybe it does not. So look at here. Here's a u in my mind. So I say, if this one is u, so if this one is u, so du is equal to what? Du is equal to 3x squared plus 1. I'm asking myself here, on dx. Here, this one all exists or not? Yes, exists. So it means that I have u du. In your book, write like that. Why u to power 5? Because here is u. That's why. Understood or not, dears? You got it? So you can solve by two methods. The first one in your book, he mentioned that, or it mentioned like that, and you see is equal to u to power 6 over 6 plus c, and I'm going to say u is that one, so I say I will write like that, x cubed plus x to power 6 plus c. This is the first method. The second method, which I'm going directly to solve for you, I say you don't need to do like that because you are in engineering, you are as a science student, so you don't need to give all these detail. I know you are good at math, so I'm going to say what? I'm going to say in my mind, that one is u. Okay, that one is u. Good. So I have u du directly because I know the derivative of here is equal to here. So directly I can write down like that, x plus x, 6 plus 6 plus c. Understood here? Up to you. Maybe you like to be like that. Maybe you like to solve like your book. Question about the first example, we're still dealing about the substitution. Substitution means that you change all these one to u. So we substitute to u. That's very important. We need this u in such critical examples. We don't need it for all of them. But in your book, it's solved by all of them by u du. So it depends on you. I'm going to use that method in a critical examples. I'm going to use u. When I say let u to be something for the criticals examples that later I'm going to show you. Okay, I'm going to show you later. Any question? It's familiar for you, that one? Easy? Good. No question? Good. So here you are. Here's the substitution and how to solve it, and you get u and you substitute u. That's all why we recall as a substitution method. Now we have another example, square root of 2 dx plus 1. So we have example square root of 2 dx plus 1 dx. So how we solve that one is very important. Again, if I have a square root or cubic root or any exponent means that if I have 2x plus 1, 3 over 2, or 1 over 2, or whatever you say minus 1 over 2. Okay. Any one of them. If you have exponent just without anything, there is nothing. Just try to find the derivative of here and try to solve it by u du. So now I'm asking myself, if I change this one to 2 dx 1 over 2 dx. Again, I'm asking myself, I have a parenthesis, I have a colon, I have a brackets. So and with exponent, with any power. So I'm asking myself again, because I have a note in my mind, I see if I have something like that, try to find the derivative. Derivative of here is equal to what? Sorry? 3 over 2? No, derivative of the inside brackets, inside parentheses. 2 dx, right? But we have what? We have no number. So I'm going to put 2 over 2. Do you agree with me? Why not? Because 2 over 2 is equal to 1. And I am going to take that one to outside. It's easy. For example, if I say 1 over 2, is good for you? Like that? Do you agree with me? Understood? Good. Now I'm asking myself again. This one is u. Derivative of here is equal to what? When I said this is u without exponent, you know. So this is just this one is u, not with the exponent. So du exists now? Yes, we have a du. So how we solve that one? I say is equal to 2x plus 1. I have 1 over 2, so I am going to plus 1 over the new exponent. Understood? But I forgot something. I forgot what? 1 over 2. You got it or not? Hello? So you don't get it. Okay, good. Repeat it again, solving again. Okay. Also here. Also here. Now here's the example. You understand the first, right? The first. We change it to the exponent. And I'm asking myself if this one is u. So derivative of here is equal to what? I say du is equal to what? I say is equal to 2 dx. But I have 1 dx. I haven't 2 dx. So how I solve this one? For a number, it's okay. You can put one of them and the other reciprocal to outside. For example, if you need 2, I'm going to put 2 here. I say is equal to 2x plus 1 over 2 dx. But we need to add 2 here. So if you add 2 here, you should add 1 over 2 outside. Why? Because if I multiply this one to inside, it should be equal to the previous one. We cannot add or subtract numbers without any mention, without any purpose, right? So we just multiply by 2. So if I multiply by 2, I should divide it by 2. Anybody, any students have a question about this step, please? Understood? Hello? Good. So now we have 1 over 2, and I am going to solve that one, this package together. So how we solve it? I say because the derivative of here exists outside, so I'm going to what? To add this exponent. So I'm going to write that one. And I'm going to add this exponent by 1 and divide by new exponent. Understood? Understood? Okay. So later we say this one will be what? 1 over 2 is outside. And here's plus c. طبعا. IC is equal to 2x plus 1, 3 over 2, because 1 over 2 plus 1 is equal to 3 over 2. Any question? Did you understand now? Shall I repeat it more? No. Okay. So that's all about substitution. That's all about substitution. You can see we have u, he called that one as u, and we have u, we have du, we put 2, 1 over 2 to outside, and here we are. It's easy, u, du, and we add, then later we will try to do it. So maybe you ask me why this result is not equal to our result, because we have 1 over 2, and I'm going to reciprocal that one. So I'll get what? 2x plus 1 over 3 over 2 plus c. That one with that one will remove, and we get 1 over 3. Let me do it for you because the first time. Maybe you needed more information. Okay. I see is equal to 1 over 2, 2 over 3, 2x plus 1, 3 over 2 plus c. Okay. Hello? Now we have what? We are going to cancel that one. So you'll get 2x plus 1, 3 over 2 plus c. That's one. Now I'm going to solve another example for you. You see, if you have f something inside it and the derivative outside it, do not forget about to add. Then simple. What do you mean by that? Here we are. So I'm going to solve secant square of 5x, okay, (5x plus 1) dx. How we solve that one? Secant square. The first example, maybe you face like that. Secant square. So how we solve that one? Before you are solving that one, you should have two important information. The first, derivative. Thank you. So if y is equal to tan of x, so derivative of tan is equal to secant square of x. That's the first. The second, you should know, you have a knowledge about secant square of x. This is the first time, that's why I mentioned that one, is equal to tan of x plus c. You should have that information, otherwise you cannot solve that one. You got it? Okay, so if the second, this is the simple, if I change that one to secant square 5x plus 1 dx. What's the change? Just we have angle changed, right? The angle changed. So in that case, we need what? We need a derivative of here. So because this is the second, and because you have a parenthesis here, and because this is a square, that's why. Because this is the direct method. So in that case, I'm going to just derivative of it is equal to what? 5, am I right? So I'm going to add 1 over 5 to outside. So in that case, IC is equal to 1 over 5. And I know this one now is like a direct, is prepared. Before that one, no, we cannot say secant square of 5x plus 1 dx. We cannot bring it to out. Why? Because we have a derivative of the angle. So derivative of the angle is equal to 5. Now I'm going to put 1 over 5 outside. Now this one is ready. When I say ready, means that is equal to tan 5x plus 1 plus c. And also we have 1 over 5. Understood, dear? You should know, I don't know if I gave you that one. You should know about these informations. Did I give you the list of the integrals? For example, sine of x is equal to minus, let me change it to the cosine. First, integral of cosine of x dx is equal to sine of x. I think this is important to be in this page. Integral of cosine of x dx is equal to sine x plus c. Second, integral of sine, yalla, finish with me. Integral of sine of x dx is equal to what? Thank you, minus cosine. Did I give you this? Did I give you that one? No, okay, so it's good. Now, integral after sine, I want a tan. If I want a tan here, I should have second square of x dx. If I want a cotan here, I should have what? Cosecant square of x dx. The other one, we need second x plus c. So here I should have second of x, tan of x dx. If you, the last one, if you have cosecant of x, cotan of x dx, then you will get minus cosecant of x. Look at the trick that I write for you here. The first is what? Positive, negative, positive, negative. Do not forget about that one. So here we have sine, cosine, not here. Okay, here we have a sine in this column, not that column. So careful. So it's better to know about that one, to put your hands in the other side and know how to find that one. Or you can review the derivative. Say derivative of cosecant is equal to minus cosecant cotan. This is very important. Please take a picture, please take a note, please write whatever you want. That's important because we are going to use again and again and again. Till Cal 2 finished, okay? Not Cal 1. So careful. Okay. Now, it was about that one. We solved it. Any question about that example? Example number 3. Any question? Hello? No question? Good. So how we solve that one? It's easier for you. I think. Now you have an idea how to solve. We have cosine, okay, 7 theta plus 1 d theta. So I know the cosine is equal to what? Cosine is equal to what? Sine, right? Is equal to sine of 7 theta plus 1. But I know, here's a problem. We need the derivative of the angle, right? So derivative of here is equal to what? 7. So we need 7, 1 over 7. That's why you can solve it. Understood? Directly put the function in case the angle need what? If the angle need a number, you can what? You can substitute it. You can put the number here and outside. Question? Any idea? Any students? You need the integral more than that you expect. So please be with me. I'm going slowly, you know. So if you have a question, do not hesitate. Just ask. Okay. Now you can see here 1 over 7 here and here and here, and you'll get the result. And here's another method to solve it. So in the trigonometric functions, without this knowledge, as addition for this knowledge, we need also the derivative of here of the angles. Write down for you. For example, I say we need the derivative of angles or angle, whatever. Next example, here we are. X squared, okay. Cosine, look at here, x cubed dx. The angle is cube, right? Not the function. That's the very important things to distinguish between them. The angle. So the derivative of angle is equal to what? That's my question. I'm looking at in that one as anything. As anything. Make the triangle in your mind. Make anything that you like. Just ask yourself, the derivative of here exists or not? So the derivative is equal to what? It was x cubed. Is equal to what? So 3x to power 2, she's right. Do we have this outside? No? Do you think we have x squared, 3x squared power, or 3x squared outside or inside here? Yeah, we have x squared. We can rearrange that one. Why not? I'm going to arrange it. Look at it. I'm saying we're right. X cubed, x squared dx. Why not? As I told you, x is very important if you don't have it. But the number, we can substitute it. Why not? We can substitute it here. Understood? If I don't have this x, it's dangerous. We cannot solve that without this x squared. Even I have an x, it's not workable. Even I have an x, but because you have an x squared, here's the derivative of here. That's why I can solve it. So I say what? So because we have the derivative, look, here's anything that you want to angle. The derivative is equal to 3x squared. So here we have x squared. So what's the missing? Just number. For number, we can add, it's okay. But if there's a variable, no. If we have something like that, we cannot solve it. Understood what I say? So, because that we can say we need to, here we are, we need to put 3 here and 1/3 outside. So I'm going to the table that I gave you before, that next page. I say directly cosine is equal to what? Is equal to sine, careful, sine of x cubed plus c. Any question here? Please ask if you didn't get the idea. Okay, now we have what? Let me check. We have another example. Oh, that one actually needs work. I'm going to solve this one later. We'll take a rest.